Welcome to RSET Online, Lecture 2, Aerospace and Navigational Instruments. So today we will discuss some of the modern aspects of aviation. The first one to be discussed is supersonic flights. The second point to be discussed about is aircraft constructed using composite materials. Then last comes blended wing body designs. Okay. Now, supersonic aircrafts are the aircrafts which fly above the speed of sound. Okay, so the first thing which comes into our intuition is that it has to be more streamlined, as in the case with reality, and the wings are of delta shape in order to produce more lift at higher altitude. And when it comes to the MOC, material of construction, you can see in the figure it is made of special materials to withstand the skin heating effect. Usually only two aircrafts are designed to cruise at supersonic speeds according to my knowledge. One is Concorde, previous passenger supersonic aircraft, and other one is Blackbird, designed by US designed for US Air Force. Okay, so the rest other military aircrafts are only designed to make supersonic burst speeds during intercepting with enemy aircraft. So those things has to be kept in your mind. This is not a viable option when compared to subsonic aircrafts because the operational costs are very high, at least 3 times higher than that of the normal subsonic aircraft. The other challenge poses is that this flies through nearly ozone layers, near ozone layers, and that creates a lot of environmental impact also, like ozone depletion, etc. So typically flights are not allowed to fly in a supersonic cruising altitude due to environmental regulations. Now the other effect which comes into picture is that of sonic boom. Sonic boom is generated by the shock wave of the aircraft. As you can see in the figure, this shock wave, when it hits brittle surface like glass, it tends to break. So the flight of supersonic aircrafts over above the land is generally not allowed by most of the countries. Okay. Now, when it comes to material of construction, modern aircrafts are built using advanced materials like reinforced carbon fiber, then special alloys made of powder metallurgy. Likewise, it goes. Airliners are forced to cut down the operating cost as well as fuel cost. Typically fuel cost is about 40 to 30% or 50% of the ticket cost. So it would be helpful if any airliner is able to purchase more fuel efficient planes. With these objectives, Boeing first launched Boeing 787 Dreamliner, which is able to cut the fuel cost about 20% per seat. Then the next innovation came from Airbus. The model is called A350, which you can see in the figure. It also has similar fuel cutting figures. So now the trend is to make the aircraft more fuel efficient in the subsonic segment, and A350 comes with an added advantage. It is able to travel faster, about 150 kilometers faster than the subsonic cruising speed. Usually aircrafts operate around 1000 kilometers or 950,000 kilometers per hour at cruising speed at higher altitude, and A350 is able to operate at 1150 kilometers per hour. So in about 6-hour journey you will be able to cut down 1 hour. This is benefited for the long haul intercontinental flight. So for a 16-hour journey, you can cut it down to 1.5 hours down. Okay, so that is the kind of innovation that is going on today. Now, when coming to the last portion, blended wing body design. This is not yet a commercial reality, is not available in passenger segment. Okay, what available today is the B-2 bomber, which is used exclusively by US military, developed by Northrop Grumman. So the advantage of blended wing body is that usually in ordinary subsonic design or supersonic design, fuselage does not give any lift. Instead, it will give only drag. The drag has to be overcome by the thrust and lift to be produced by the wings. Now, when it comes to blended wing body, what you see is only a wing structure. The body is blended, or fuselage is blended into the wing, and it is shaped such that the fuselage is also able to contribute to the lift of the aircraft. Now, the problem with this kind of structures is that this was experimental from early 1950 onwards, but still only the successful case was B-2 bomber from Northrop. The issues with blended body wing design is that the structure is not aerodynamically stable, so we need to have control surface to stabilize the aircraft, and the control system of this aircraft is much complicated. We need at least 2 or 3 supercomputers to fly B-2 bomber. So lot of stabilizing algorithms has to run with only computers can stabilize the flight. Okay, so a lot of stabilizing algorithm has to run in parallel, and this is computationally too expensive. And when you come to theoretical or academic interest, the system is not fully state controllable, or just like similar to any other aircraft, but this have the problem of controllability and stability. So we need to stabilize this structure during aerodynamics or during the flight. Then the next issue to be overcome is the structural mechanism. The structural analysis of the modern aircraft is highly matured area. Nowadays we are having less number of structural failures. Most of the accidents, structural issues are not contributing to the accidents today because we have enough knowledge regarding that area. But when it comes to blended wing body, it is very difficult to even have windows. So that will be in a closed contour, maybe fitted with TV screens to show the external view. Only that much is available. It's very difficult to create windows. Only windows that would be available is for piloting purpose or for placing camera purpose. And this aircraft is highly researched by both Boeing, NASA and Airbus. Of course, not in a collaborative program, but independent projects. As I told you before, this offers great advantage over fuel price. At least you can save 40% of the fuel cost, because the fuselage itself is able to create lift or add to the lift mechanism. Okay, but still experimental. We need to go a long way in order to get this aircraft certified for passengers needs or passenger standards, to meet the passenger requirements. Now you can see the pictures from Boeing's site regarding the experimental aircraft. In fact, MIT, Caltech and Stanford University all are participating in this Boeing's project along with NASA. So that is one of the highly researched area. a lot of opportunities for you to dwell. Many of you can even do some kind of course simulation between ANSYS and MATLAB, so that the computational fluid dynamics part can be done in ANSYS and the control part can be done with MATLAB Simulink, and create course simulations and submit papers for the design contests, which will be usually called by Boeing, NASA or MIT universities, and grab your seat for masters or PhD programs. So I encourage you to do such. It's not very easy, but if you have contacts with some of your seniors or any other people who are working in this area, you can do this comms simulation with ANSYS and MATLAB, and try come up with some new algorithms for stabilizing this kind of structures, so you will be highly rewarded. So closing the session for this time. See you on another occasion. Thank you very much for listening.